um, Module 5, that is the design of journal bearings. So procedure steps for journal bearing. So journal bearing, so as you can see, it's a journal bearing with the load W applied. So the shaft or journal called as journal is called as shaft is having diameter D, and C is the clearance between these two. So let D is the diameter of the shaft, or also called a journal. C is the diameter clearance, so this is the clearance gap. L is the length of the bearing, means from where to where the bearing is being held, is called length of the bearing. Psi is the diameter clearance ratio, C by D. N is the absolute viscosity in Pascal. Suppose it is runs in an oil, and that oil has a viscosity nu. N is the speed in RPM, that is rotational speed, and dash speed in RPS, that is N by 60. Next is the bearing pressure. For that W load, for this W load, the bearing pressure is W by LD. W is applied load, T is the operating temperature in degree centigrade, T is the bearing temperature, T is ambient temperature. Mu is the coefficient of friction, H minimum is the minimum film thickness, V is the velocity, pi dn by 60 meters per second, S dash is the bearing modulus, B is the angle of bearing, 360 for full journal bearing, Q is the quantity of oil flow, and mu is power lost in friction. Now starting the procedure, design procedure for journal bearing. So type 1, to find Sommerfeld number, coefficient of friction, heat generated, and power loss. So given data, so the length of the bearing L will be given, L dash mm, diameter of bearing D will be given dash mm, load W dash Newton will be given, speed of journal dash RPM will be given, viscosity nu will be given Pascal second, or if not, or grade of the oil will be given, that is for example SA10 at operating temperature 60 degrees. So when grade of oil is given, the SA is 10 at operating temperature 60 degrees, refer table 24.1 for SA10 and choose and see where it falls under A, B, C, D or E category. So if after selecting the category, so refer figure 24.2, figure 24.2 for operating temperature 60 degrees and A, B, C, D, E category. So find the viscosity mu equals to centipoise. We get it answer centipoise. So multiply with 10 to the minus 3, we get Pascal second. And lastly, diameter clearance ratio C by D or psi will be given. Step 1, to find speed in RPS, bearing pressure and velocity. So speed in RPS N dash is N by 60 in dash RPS. Bearing pressure P is W by LD, that is dash Newton per mm square. If W is in Newton, L is in mm, D is in mm, Newton per mm square. Velocity V is pi dn by 60. If D is in diameter, so it's meters per second. Step 2, to find Sommerfeld number. So this formula N nu N dash B into 1 by psi square. So this formula will get in volume 2, so near the introduction part. So therefore S equals to dash. So step 3, to find coefficient of friction. So there are two different equations. So first is Petrov's equation, mu is 2 pi square n, mu n dash b upon 1 by psi, 24.21 equation number. One more is Mackey's equation, mu is ka, mu n dash b 1 by psi 10 raised to minus 10 into delta mu, 24.22. So ka is 1.9 by 10 raised to 11, delta mu is 0.002. This we get near equation number 24.22. So either you can use any one of it, any one equation you can use unless mentioned. Now step 4, heat generated. Formula Hg is mu PLD into V is equation number 24.72a or mu WV. So we get the watts in terms of watts Hg. Lastly, step 5, power loss in friction. N mu is mu WV upon 1000 in kilowatts. We get the answer in kilowatts.